Matrix.org is an open source project. We are a non-profit initiative dedicated to solving the problem of fragmentation in communication that we see today. So I'm going to talk to you for the next hour about this. If anybody has any questions at any point, and I have any hope of understanding them, please interrupt, please stand on your chair and shout at me, or otherwise try to point me in the right direction. So the problem that we see in Matrix today is that users are locked into proprietary communication apps. I'm sure that everybody here has probably got 10, 20 apps on their phone. They've got WhatsApp, Facebook, Hangouts, the entire spectrum of all of these solutions which are out there today. And from a user perspective, it's really starting to be a problem. Users are losing control over their information, over their data, over their privacy. Now, 5, 10 years ago, perhaps this seemed to not be a major concern. Hey, I'm going to use Google for all of my information. But as more and more possibilities appear for applications to use, and we see more and more instances where people's conversations are being sold or mined or otherwise subverted, I think that even the normal end user on the street is wondering why they are so totally dependent on Facebook or Google or whoever it might be. Now worse still, all of these apps are a closed silo, so the users end up having to install many, many different apps which basically do the same thing, and it really fragments where their conversation history is and where their contacts are. So the diagram that we typically look at here is if you have Bob wanting to talk to Alice over there, superficially, all the choice. How will he do it? Will he use Viber? Will he use Hangouts? Skype perhaps? And depending on which one he uses, he has a whole different set of identity problems to identify how to talk to Alice. But the reality is that this isn't choice. This is actually a real usability problem. If I want to have a video call with Paul right now, I have no idea how to do it. Am I going to guess him on Skype and try to recognize him from his face? Am I going to put his email address into iMessage and hope that FaceTime works? I don't know. Do you use iOS or Android? It's a real problem. So our thesis is that I want to communicate using the apps and services that I pick and I trust. I do not want to be forced into installing Skype or whatever it is chosen by the people I want to talk to. Now, if email, which is terrible, email is crap, it's terrible in so many ways, except it gives us this flexibility in that I can use whatever mail client I like, I can use whatever email server I like, and we can talk to one another. We've ended up in this crazy world where email is pretty much the only mechanism we have in common to talk to one another. That and the phone network. So why do we still not have this with VoIP and instant messages? So Matrix is a potential solution to this. Obviously there are many other technologies trying to solve the same thing, be it SIP, which I'm sure everybody is aware of here, or XMPP, but I'm going to talk about Matrix specifically today. So for the real geeks in the audience, the way to think of Matrix is as an open, decentralized, persistent, eventually consistent, cryptographically secure messaging database with a JSON over HTTP API. I'm sorry that I probably lost half the people in the room, and this looks like a lot of impressive words meaning nothing, but we actually mean all of this. So Matrix is a completely open standard and an open protocol. Anybody can implement it to communicate. It's completely decentralized in that there is no single server and no single company who controls your communication. So it's not like Slack or Facebook, where you have a single company which everything goes through. The whole point of Matrix, and the reason it's called Matrix, is because your conversations are matrix. They are distributed over all the different people who are participating. So if I have a conversation with, again, Paul, just to pick on him because he's there, and I know someone else here, and we all have our own servers, there is no single server who owns that chat group, that conversation, that video call. It's like email, and it's not like the Facebooks and the Googles we know today. In the end, it's just a messaging database. It's a way of publishing some data on the web and having somebody else receive it. I'm sure many of you know that the web was originally meant to be a read-write system. It was meant to be a way for people to publish and consume data in a consistent manner. And it all went terribly wrong because it got too popular too quickly. Everybody consumes data through web browsers, but if I want to publish on the web, it's a mess. It could be FTP, it could be WordPress, who knows? Matrix is providing both a standard for publishing and receiving in real-time information on the web. So what can you do with this thing? Well, our main use case is a group chat, and it happens that one-to-one chat is a subset of group chat. You could use it for WebRTC or VoIP signaling of any kind. So if you want to set up a call between two browsers using websites from different people, or applications or devices from different people, Matrix provides a standard signaling layer to do that. You can use it to bridge together these existing silos. So if you want to plug Slack and Link and Skype and IRC all into one single unified view of a conversation, the Matrix gives you a way to matrix that together. And finally, a really interesting thing here could be to use it as a fabric for exchanging Internet of Things data. So we have all these devices which just want to publish information. They want to publish the temperature. They want to publish a location. At the moment, everybody invents their own API for doing this, or there are some really complicated ones which are trying to be optimized for this. Why not just publish it via HTTP? And in the end, you can use it for anything that wants to parse up persistent data to the world. Again, for the geeks who are familiar with IRC and XMPP scrollback, you can think of Matrix almost as a data liberation operation to give you control of your conversations, to give you control over your scrollback. So another way of looking at this is three different angles. We have three laws. The first one is that Matrix is all about conversation history. It's not like SIP, where you're setting up a phone call from A to B. It's not like XMPP, which is typically sending an XML stanza from A to B. Instead, we are synchronizing message history between completely separate servers. Also, it's all about group communications. So again, if you look at SIP, if you want to do a group call in SIP, you need an MCU, you need a conference server. In XMPP, you need an MUC, whereas in Matrix, everything is grouped from the outset. Second law, no single party owns those conversations. They are shared over everybody participating in them. And this is probably the most important thing in Matrix, because it's really quite subversive. It means that there can be, that actively sending a message to somebody forces that message to be shared between two different companies. You cannot create a silo in Matrix by definition. And then finally, everything may be end-to-end encrypted. End-to-end encryption is optional because there are some devices which aren't going to be smart enough to do it. But in any given room, I can configure a room to say, hey, everything in here has to be end-to-end encrypted. And this means not that you're using HTTPS, although you are. It means that even if the server gets compromised, nobody can see the conversation because only the users at the perimeter, at the edge of the network, can decrypt and encrypt these messages. This is happening real soon now because we've implemented all the hard bits, but we haven't quite finished integrating it with Matrix itself. I'll talk a bit more about that later. So, just to summarize, Matrix is a non-profit open source project. We provide de facto standard, open standard HTTP APIs, and these come in three different flavors. There are the ones between Matrix clients and Matrix servers, the ones which cause Matrix servers talk to one another, then probably one of the most exciting ones are application services, which is how you extend Matrix. If you want to bridge to SIP, bridge to, I don't know, Asterisk running in Elastix, then you would do that using an application service, or really any additional server-side functionality. But it's not just a standard, this isn't vaporware. We have actual implementations. Everything is Apache licensed open source. We provide a reference server called Synapse. We provide client SDKs on a whole bunch of different platforms. We provide example white-labeled clients on web and iOS and Android. And finally, we provide a whole bunch of different bridges and application services, linking Matrix to IRC, to SIP, XMPP, Link, and a whole bunch of others I'll talk about. And finally, it's also an ecosystem. It's not just a bunch of geeks having a fun on an open source project. We've got a really big ecosystem of third-party developers building servers, clients, and services and solutions on top of Matrix. But enough talking. Well, what does this actually look like? So, if you go to matrix.org and look at, probably one of the first things you're going to see is this page here, which is try it now. And this is a list of all the things which have been built on Matrix. The easiest way to get started is to pick a client. If you're a real geek, you might want a command line one. If you prefer glossy things, you might want a glossy web app. Perhaps you want a more ugly but functional developer console. Alternatively, there are loads of other ones from different people. Most of them are command line at this point. Perhaps you want to run a server. Well, there's a choice of actually 4. We need to add one to this right now. Synapse is the main one that we provide, but there are a bunch of more experimental ones if you like Go or if you like Java. Synapse is written in Python. And finally, there are all of the bridges, IRC, SMS, INS, generic libraries for writing them, XMPP in many different languages, and finally the SDKs. So what you typically do is probably say, hey, I like glossy clients, and click on Vector, which will go and take you to something that looks a bit like this. So this is a Matrix client. This is Vector, which is written on top of the Matrix React SDK. As you can see, we've got some photos in here of the room filling up earlier on. We've also got lots of chat. In the room itself, we've got about 1,500 people. Here I can quickly scroll down. They're from all over the place. Some of them are running their own servers. I don't know if anybody can read, but his Matrix ID is at rgh on matrix.dgxz or dz.net, because he's running his own server. Meanwhile, this guy is at $1 on matrix.org. So in this room is replicated over 400 different servers. It's got 1,500 people in it, and a history of hundreds of thousands of messages that goes back to day 1 of Matrix last year, because it was the first room that we created. More interestingly, we've got people going and sort of using this from different platforms. So you can see someone, or me actually, on Slack there talking. There's probably people talking here on IRC as well. And I'll show you the bridging. Yeah, there's someone on IRC. And I'll show you that in more detail in a minute. So I've probably got 500, 600 rooms going on here. Some of them are one-on-one conversations. Some of them are group conversations. Some of them are bridged into other networks, and some of them are standalone. But say you wanted to look at a different client. You might have picked, let's see, this one. So this is precisely the same room, but viewed by a completely different client. This one is written in Angular, and it's a bit more functional, but it's got some performance problems. But it's really interesting in that if you go and zoom in on it, like that, and you double-click on a message like that one, it actually shows you what's going on under the hood of Matrix. You have the JSON in here showing the body and the message time and the timestamp and a couple of other bits. But basically, to send that message in Matrix, all you have to do is a single HTTP hit to send a message, and everybody in the room does a single HTTP hit to receive the message. And that's it. So for instant messaging, you're thinking probably, hey, loads of messaging APIs are just that. But it gets a bit more interesting if you look at WebRTC. So if I have 2 clients here, and I go into a room with myself, so this one is logged in as Evil Matthew, because he's wearing a suit and has had a haircut, a bit like I have today. Whereas this one is logged in as Normal Matthew. You can see that there's a conversation going on between the two. Right, so not very exciting. You have typing notifications here, so if I start typing, you can see that I'm typing there, and then it goes grey until it's sent, and then it comes through. We also have desktop notifications, and I've also got the clients installed on my phone, so I'm also getting them as push notifications on my iPhone. If I hit the video call button here, it will go and fire up a video call between the two. Not very exciting, because obviously it's the same camera on both of them, but you saw that was a very fast setup, despite the fact it was going via the Matrix server, which is running in Europe, using trickle ice to negotiate the call. And I can go and hang up on it. I can also talk at the same time if I so wanted. Now, if we actually go back to the geeky client here and look at what just happened, then you can see there's an outgoing call clip here. If I double click on that, then I can see the underlying matrix stuff in a lot more detail. And for anybody who knows or has the displeasure of knowing STP, you'll see that there is an STP offer in there that is taken straight out of WebRTC, and then it's bundled up as JSON as an offer. So it's again one HTTP ahead to send an offer, one HTTP ahead to do the answer, and you're in a call. In my mind, this is a huge improvement over SERP. Looking at something else like an image, again, it's just JSON. You've got a MIME type, width, height, size, file name, that sort of thing. We actually include a distributed file repository as part of Matrix too. So the point here is that you can put any JSON into Matrix, it goes into a room, and it is replicated over the people in that room. So that's what it looks like. Go on, PowerPoint. There we go. So looking at the overall ecosystem that we have today, the main deliverable that you get with Matrix is the Matrix specification itself. This is just a single document that defines the HTTP APIs, that define how servers talk to clients, how application services talk to servers, and how servers talk to one another. Synapse is our main reference, one in Python. We have all of our application services doing the bridging. These are typically written in Node. And then you have, in orange, third-party servers and services that other folks have written. On the client side, you've got loads of third-party clients, which we looked at earlier, and then it's split into Android and iOS and the web. On the web side, we have both a React SDK, which is what Vector is written in, that we were just looking at, Angular, which is what the uglier one was written in, and then we have full-blown applications on top, Vector on React, Web Console on Angular, iOS Console, which you can get from the App Store right now, and Android, likewise, which is on the Google Play Store right now. All of these are Apache licensed, so if you wanted a quick way to get up and running with either a white labeled app or to use the SDKs, we have reusable user interface stuff in the middle there here between Matrix Kit and React and Angular. We've got the low-level HTTP SDK and then the actual application sitting on top. Architecturally, this is a really simple view of what's going on. You've got 3 servers here, which share a conversation between them. Each server has clients associated with it. You've got the application services, which are basically an oversized client that does all of the interesting extensibility stuff. And then you have identity servers. And identity servers map from real-world identity to matrix IDs. I'm not going to talk that much about identity because it's literally a 3-hour seminar to discuss it. A colleague of mine was just given one on Monday and ran out of time despite having 3 hours to talk about identity. But the idea in Matrix is that you would not have a Matrix ID on your business card. Instead, we just use the IDs that people have today. If I want to call somebody and I know their phone number, then I would ask the Matrix identity servers, how do I talk to this phone number? If I had their email address, again, it gets resolved to a Matrix ID, but critically, the ID is internal, it's private. So, I talked about the functional responsibility. How does it actually work? We've seen what the user sees, but let's quickly go behind the scenes and look at what is actually happening at the protocol layer. And to help me with this, I have a pretty animation. It's somewhere. Where's it gone? There it is. Oops. Let me quickly remove this. So here's an animation showing 3 Matrix servers and 3 clients. And these guys, Alice, Bob, and Charlie, are all in the same room. What happens is that Alice starts a conversation with an HTTP request to send hello into that room onto her server. The server stores it, as part of a directed acyclic graph data structure that gets gradually built up over time on her server, cryptographically signs it, and then pushes it to Bob and Charlie's server. And again, that's the actual curl request for the HTTPS that does that. And interestingly, it's been signed with the key of Alice's server to make sure that it really came from Alice's server. This isn't an end-to-end encrypted room, this is just normal matrix. Bob and Charlie's servers store it there, and at this point, we've got 3 copies of the room, all in sync over those 3 servers. Now, that message will get pushed down to Bob and Charlie, at which point Alice has communicated to Bob and Charlie. It's all good. Now, if Bob responds, his message is going to go into this data structure showing that message 2 came after message 1. And say that at the same time Charlie also responded, at this point we have a race between Charlie saying hi and Bob saying hi. So all the copies of the room are out of sync, but actually that's not a problem. That's fine, because Matrix is designed to allow the different servers to slightly get out of sync and then converge again. So what happens actually is that Bob's message goes through to Alice and Charlie and causes a split in the data structure here, saying that both message 2 and 3 came after 1, and we don't know which happened first. Then Charlie's message gets pushed out too, and at this point it's great news because all 3 servers have got the same image of the room. And if Alice says something later, then it just heals the split, and you end up with all servers having the same copy of the room. So this is really what's going on. We're taking this conversation and we are decentralizing it over the servers. It's a lot like Bitcoin or blockchain, except for conversation rather than money. Or it's also a lot like Git, if people are familiar with distributed DCS systems. So, if you're actually using the API itself and you're developing, I don't know, Asterisk plugin or something for this, then to send a message, it is literally just post the JSON, give it a message type, the body of the message, and an event type of that data to the right API on the server, and you get back an event ID. We've already spoken about a WebRTC call. It's a bit more complicated. You have the offer, you have the SDP, and the data type here, the event type here is an endcall invite. And what happens is that the caller sends an invite, trickles some nice candidates, the user answers, media flows, and then somebody hangs up. So in practice, we only have 4 different types of events here. It's pretty basic, but it works absolutely fine. Something a bit more exciting and fun that we did was to go and relay MIDI over Matrix. So if folks are familiar with MIDI as digital music protocol, what we did was to take a piano keyboard, a synthesizer with a MIDI controller, and captured its MIDI, put it into Matrix, and wrote an extension to a Matrix client that notated the music on a musical stave in real time so you could see what the person is playing. Just an example of something completely different being used going over Matrix. And the even cooler one we did, in my mind, was because it's called Matrix, you have to have a virtual world thing going on in here. So we took some 3D avatars and we put them into Matrix and we controlled them over Matrix. So the room literally became a virtual world with these 3D stickmen in it being animated to interact with one another. I'm sure you can imagine what happened. So that's client-server examples. The server-server API is more complicated. Don't worry, I'm not going to try to talk you through that. But suffice it to say, there's a lot more encryption in here to avoid spoofing, and we also cryptographically sign all of the nodes in the data structure so people can't tamper with history. Because this is really important. If you have democratized the conversation, you don't want somebody lying about who said what. So that's kind of the baseline of Matrix. That's the core information about what Matrix is and how it behaves. Let's talk about some new stuff, some of which is very, very new, and we're announcing for the first time here at ElastixWorld today. Application services is where an awful lot of our effort has gone recently. So this is extensible custom application logic. These guys are a bit like IRC services, if you know how IRC works. They have privileged access to the server, so they can do things like sniff all of the messages going through the server. So if you wanted to write a search engine, then you would write an application service that subscribe to all the traffic going through your server and put it into Elasticsearch or put it into Solar or whatever your preferred search engine was. They can subscribe to literally anything, and they can also, and this is the really powerful thing, they can masquerade as virtual users, and they can also create virtual rooms. So a single application service can extend the entirety of Matrix into bridging with other ecosystems, other applications. And we call this a bridge because it's obviously building bridges between these islands which wouldn't otherwise be able to talk to one another. So the primary use for the application services API is gateways, but you can also imagine a lot of data manipulation here. If you wanted to filter down IoT data, if you wanted to do machine translation from English into Spanish, if you wanted to index the data, or mine it, or visualize it, and some kind of orchestration where you're deploying things over Matrix, this is where you do the custom functionality. And you can also create IVR services, or bots, or whatever with it. So the architecture of Matrix is that it's meant to be really easy to write clients. Now I can write a client with a one-liner of curl, and it should be also really easy to write application services. So that is a complete application service written in Python using the Flask Web API. And what it's doing is defining an endpoint called transactions, and every time it receives a transaction, it just logs what was going on. So user in this room did this event with this content and shows the JSON, and that's all it does. And you can just imagine that this is the starting point for building any level of additional functionality on top. So thinking more about bridging, the typical architecture is we have the same matrix diagram that we had before with your servers here and your clients. But if you have your application service acting as a bridge, then you can take an existing app, something like, say, Slack or FreeSwitch or Asterisk, and use that to then talk to the existing servers together. So the first one that we did, right back about a year ago now, was IRC. So right now you can access all of the major IRC networks through Matrix, thanks to Freenode and Mosnet and others being very helpful and allowing us to integrate with them at a pretty deep level. We have a bridge running that allows people to participate directly through Matrix. And probably the best way to show this is to actually do it. So if we go back to the big room, Matrix HQ, here. No, not here, where's it gone? Let me find it. Oh, there we go. So this room here, oh, hello, we've got Cycle, thanks Cycle, going into taking photos from the audience there. If we went to look at this in IRC, so thanks Cycle. Here is good old IRC. You can see in the time it took me to Alt-Tab from Matrix over to XChat, you have both Cycle and myself in Matrix here going and chatting away. As it happens, we've prefixed everybody from Matrix with N, but if you look at the membership list here, obviously there's a bunch of people from Matrix, but there's almost an equal number participating through normal IRC. So my nickname on IRC is Arathorn for various very geeky, embarrassing reasons. So if I go and say I wave from IRC, then there we go, in comes the push notification from, in this instance, Vector, but it also came in here. So you get an idea of the scope of this. Now another bridge that we built very recently, and this is I think the first or second time we've spoken about it in public, was a Slack bridge. I'm sure that many people are familiar with Slack as this proprietary software as a service solution for chatting, but you can see it's precisely the same view going on here in Hash Matrix, with Cycle and myself, both from IRC and from Matrix chatting together. So we've really taken this room and we have liberated it from Slack, we've liberated it from IRC. It is existing in this kind of liminal state between the different networks. So I'm going to wave from Slack as well, just because I can. And hopefully that will come through too. So we can quickly go back to the presentation and we'll kill that so we don't have to keep switching between full screen. There we go. So we looked at the IRC one, we looked at the Slack one. SMS is a fun one. So the Open Market is a company associated with Matrix who runs an SMS gateway, and what they've done is to go and build a bridge that allows anybody from Matrix to just start sending SMS to anybody on the PSTN as a kind of standard HTTP API for doing that. I haven't actually tried doing this recently, but here is one of the conversations here between my phone number and me testing it. Hello, does this work? And because I'm roaming here in Colombia, the chances that the SMS is actually getting through to my phone are fairly slim, but I'll let you know if it does actually make it through. And it actually works two ways. Oh, there we go, there it is. Nobody can see it apart from people in the front row, but perhaps you can attest that indeed the number is saying, hello, does this work? I should even be able to respond to the phone number which has been allocated for my Matrix user. I say hi there in response. It's gone out as an SMS. And again, modulo international roaming at some point. There we go, and we get the hi there coming in at the bottom. So two-way SMS bridge going on there. What else can we bridge? Free switch. So I'm afraid that we don't have an asterisk bridge yet, although we're working on it hard in America. I'm trying to write it whilst flying back and forth between the Americas and Europe. But we do have one for free switch called Matrix App Service Verter, which works today, and it means that you bridge all of SIP via a free switch into Matrix. And we do this using a protocol called Verto that FreeSwitch had invented that is quite similar to Matrix. So it's actually a really, really simple bridge to go and take a Matrix MCall invite and turn it into a Verto invite. Unfortunately, they don't do triple ICE, so we have some mismatches there. But you get the idea that we're really just conversing between the protocols of these very similar things, except in a standard manner. And actually, talking about the Slack bridge quickly, if I go onto GitHub and look at our app service bridge, this is a library we use to build node bridges, and it's got a how-to here. And if anybody is interested in writing JavaScript in Node, then I strongly recommend having a look at this because it's not lying when it says this how-to will explain how to write a matrix to Slack bridge in 100 lines of code. And it talks you through the whole thing in 100 lines of JavaScript and gives you precisely the Slack bridge that we were just looking at. So you get an idea of how easy it is to build these things. Now, it was so easy, and in fact that's an example of the free switch bridge being used to do multi-way conferencing on Matrix. I won't try doing it from here because the internet access isn't great, but suffice it to say that's using free switch behind the scenes. Now, the architecture of the bridges is that you have, in our typical implementation, you can write them in any language, but our default one is to run it on Node. We have the Matrix JavaScript SDK, which is the same as the clients use. We then have a Node library for doing any kind of app service, a bridge-specific library, and then on top you have the IRC, the Slack, the Verto, and whatever other bridges you want. So a really interesting one that we wrote over the last couple of days, and this is the first time we're speaking about it, was to take a library called libpurple that people might know about from Pigeon or Game or Adyen. And this is a library that can talk to lots and lots of different protocols. I think it supports about 25 different ones, and they range from old school ICQ and AOL Instant Messenger all the way up to Skype and Link and Facebook and other more modern communication things. And what we did was to take libpurple, put it into our Node application service, thanks to support from the Node and the libuv community, and then it basically allows us to bridge any of these things in a basic manner into Matrix. So this is the first time we've ever tried to do this demo, so it probably won't work. But what I have here is Skype, logged in as me, and I've got a user here called Matrix Demo who is bridged through into the main, or into one of my conversations there on Matrix. So if I go and find a Matrix client and go and look for the Skype demo here, there it is. Right, my demos never work, right? Oh, almost immediately in Skype, we have it coming straight through there, and can I respond? Let's go and put them side by side. Wow, that's incredibly fast. So here we have, shown for the first time at ElastixWorld, ladies and gentlemen, Skype to matrix bridging. At the moment, it's just one-to-one, but it will be a simple matter of programming to extend it to do full group chat replication. So you can now imagine that we've got IRC, bridge to Slack, bridge to Skype, bridge to matrix, and really the end game that we're going for here is to provide come back to that one, a universal decentralized fabric that can link all of these different silos together. The final silo we haven't spoken about that much is Internet of Things. And a fun demo that I sometimes do, but I'm afraid I don't have here today, is to take a drone. This is a Parrot Bebop drone, which has WebRTC, it has H.264 video on it, and it provides a C API actually on the device itself that allows you to get at the video, and it allows you to control, to launch, to land, to fly this thing around. And what we did was to take the Janus WebRTC gateway, written by a company called Meetecho, which is an amazing piece of kit, if anybody's played with it, and we added a matrix interface to it so that it could talk to the matrix ecosystem there as an application service, and we added a drone driver to it so that it could talk to the horrible C API that you get off this drone. And hey presto, it actually works. I'm sorry I don't have it with me today, the drone's broken, plus I was worried about getting it into the country. But actually, this was written on a plane. If you ever want to get really strange looks, sit on a plane with a drone next to you and a laptop and start programming the drone. The cabin crew get quite confused. But either way, it works, and it means that any matrix client at all, so hypothetically it could be Link or Skype, or it could be a native matrix client on mobile or web, can suddenly launch this thing by literally typing launch, return, and then get the video feed coming back in a completely vendor and platform agnostic manner. So it's really making communication as interoperable as email. So, I think we've probably bridged demoing by now. Other stuff. The React SDK is what is powering the web app bit. We're quite proud of this because it's really quite performant. So if I switch to a room here in React, like Matrix HQ, with a few thousand people in it, it's almost instant to change over. And it's all happening client-side, it's all JavaScript. If I compare that with doing it here on the old Angular client, then let's see, start 1, 2, 3, 4, about 5 seconds to switch between tabs. Now, that's not really Angular's fault, it's really our fault for writing crap JavaScript. But it gives you an idea of the performance of the React SDK we have there. And the architecture of the SDK looks like this. So you've got your browser at the base, you have the same JavaScript SDK that you would use on application services, and sitting alongside it is the React framework from Facebook. On top of that, we have the controllers. So this is really the reusable user interface elements of the app. On top of that, you've got the views, you've got the skin, you've got the CSS that actually make it look like vector. And you can use the skin two ways. Either you can fork the skin and create vector, or you can build on top of the skin and customize it in order to make a new application like Matrix React console there. So if you're wanting to quickly add communication capabilities to a website, you have a whole range of potential. You can talk HTTP directly, you can use the HTTP wrappers, you can reuse our existing components, at which point you have to use React. But React works nicely with other libraries and other frameworks, so you can just have bits of the app implemented in it. And personally, this is something I'm really excited about because it has the ability to put in as much or as little matrix functionality into any website that you want. Something completely different is our end-to-end encryption. So our end-to-end encryption is called OLM. It's an implementation of a cryptographic ratchet called axolotl, which is, I believe, a type of Mexican salamander, possibly. Well, an OLM is a European salamander that you find in certain countries in Central Europe. And what OLM is an Apache licensed C++ implementation of this ratchet. Now, axolotl is written by a company called Open Whisper Systems. If you know what OTR is from the XMPP world, this is much better than OTR. It supports group communication, it's asynchronous, and in practice, our implementation is very small. It's 100K of native code or 200K transpiled to JavaScript. And what Elm does is to provide a way for parties in a room to talk to one another with complete encryption, so that nobody intercepting the data can see who is talking or what is being said to each other. Architecturally, you get a C API and you have various different components sitting within it. You have the concept of an account, you have a session, you have the ratchet itself, and a ratchet is something that generates a series of keys. So basically everybody in the room ends up with this algorithm that keeps generating new keys for every message, so everybody can keep in sync without ever leaking those keys to anybody else. And cryptographically, it's built on elliptic curves and AES and using SHA-256 for hashing. Now, unless anybody really likes cryptography, I'm not going to go into this in huge amounts of detail, but suffice it to say that the implementation of axolotl is basically that Alice and Bob have private keys, which they keep to themselves, but for every session, they also generate ephemeral keys. And the cool thing is that you have this triple ECDH, elliptic curve diffie-Hellman handshake, that allows each new conversation between Alice and Bob to be tied both to their real identity and to this temporary session that they've established. Now, a whole bunch of stuff happens here, which eventually ends up with them calculating some parameters that they can pass over to Bob, which he can then use to compute the same initial shared secret of his ratchet. So basically, they're synchronizing their watches, they're synchronizing their ratchets together to generate the same keys. And what happens is that for a consecutive series of messages from Alice or Bob, you use the same base key, but when the conversation turns over, so when Bob responds to Alice, you create a new session. And the way that Trevor Perrin, who invented Axolotl, shows this is that you have an initial key at the top, and then you have chains of message keys and Ks coming off either side, depending on who's speaking. So it could be Alice speaking, then Bob speaking, then Alice and Bob speaking. So you're creating this cascade of messages, which in practice is very hard to crack. And in fact, it's, I think, infamous in the WikiLeaks stuff that OTR, which is like the simpler version of this, hadn't been cracked, and Axolotl is even more so. I can show you a quick demo of this. It's not very exciting, I'm afraid, but you have to believe me when I say it works. If we go, this is a JavaScript implementation of Axolotl. So it's actually the C code compiled down to JavaScript using Emscripten. And it says like Alice here and Bob at the bottom. And if Alice says something like, "Hello world," and hits encrypt, then you get this encrypted JSON blob, which has the ephemeral keys at the beginning, and then the ephemeral public keys at the beginning, and then the actual message starting with that there, starting with the plus there. And if we click on that, then we can copy it down here to the decryption window, and hit decrypt on it, and hey presto, Bob has decrypted hello world. You have to believe that that did actually go through the entire old ratchet, and we didn't just copy hello world from there to there. Now, if Bob wants to respond, then he has to create a new chain. So, in fact, if we send something else here, how's it going? ElastixWorld, and hit encrypt, we actually get a smaller message, slightly smaller message here, I think. No, I confused it. Never mind. But basically, you get another message, which we can hit decrypt on there. How's it going, ElastixWorld? If I try to decrypt it again, it won't work. I'll get an Axolotl bad message back. If I respond, I'm doing great. Hope I'm not boring everyone. And hit encrypt and copy that over and decrypt it there. Then you get the idea that basically you're passing these messages back and forth. Now you're probably wondering, that's all very well for Alice and Bob, but what about group chat? Well, group chat is actually an extension in that you create a third ratchet that has to be synchronized between everybody in the room. So you establish one-to-one branches between Alice and Bob, Alice and Charlie, and once they're sorted out, then you can use those one-to-one conversations to set up the group ratchet that encrypts the whole room. The end result is that all of the participants share the same ratchet state when they're decrypting the room. Now, really fun thing about the privacy you get with ON is that we can configure our rooms to be quite flexible. So you can create a room and say, no ratchet, no encryption at all. And that would be really useful for, say, an IoT scenario where your drone is never going to speak, or your thermometer is never going to want to do encryption. Also, if you're bridging to something like Slack, which does not and cannot do end-to-end encryption, you're going to have to decrypt the room to let the other guys in. But if you want a native matrix room, or which can talk to other Axelot or OLM-aware networks, then you have the option of full perfectly forward security, where every single message can only ever be decoded once, and then you throw away the key, which is great from a paranoia perspective, because only you can ever have decrypted that message once. But in practice, it's actually a huge problem for Matrix, because Matrix is all about conversation history. It's no good if I look at the room on my phone and then look at the room on the web browser. I can't read it on the web browser because it's already been read on the phone. So what we've come up with is this idea of a selective ratchet, which says that you can rekey the room, not for every message, but when you want. So when a user joins the room or leaves the room, that gives you the opportunity to change the key on the door to lock the new person out from seeing the history or not. So it's not quite as secure as PFS, but practically speaking, it's really useful in terms of defining these epochs of history in the room, which you allow people to read or not read. So where are we at? Right now, we got funded to start this back in May of last year, and we launched a very early alpha in September. We started beta and got generally feature complete in December, and since then, we've really been doing an awful lot of debugging and re-implementation. We shifted from Angular to React, and shifted from SQLite to Postgres, all kinds of big re-architectures in order to make the thing performant and work well. We got to a stable beta in May, and since then we've been adding in things like the end-to-end crypto and React in July. For the last 2 months we've been doing lots of bridging, performance work. We've made the spec much better. If you like specs, now I no longer feel embarrassed to tell people to read our spec. And finally, conferencing, as I showed the screenshot of earlier, is a fun thing to do. What comes next? We have a couple of rethought APIs which will speed it up enormously. We need to use third-party IDs everywhere. We need to actually roll out end-to-end encryption beyond the demo you just saw. Lots more bridges. We have a lot more performance work to be done. The spec was looking good, still has a lot more to be done. And probably most excitingly, we need more server implementations, because the Synapse implementation that we started with in Python and Twisted was great as an initial proof of concept to rapidly iterate on the APIs and play with. But in terms of the overall performance, if we're really scaling it up to hundreds, millions of users and transactions a second, we really want something a bit more native, possibly something with better typing, and we're currently looking at splitting Synapse into different services and implementing them in whatever language makes the most sense. Sometimes that could be Python, but in practice I'm expecting some will be in Go, might be in Rust, C, C++, whatever language makes the most sense. We need help in many ways. So, as I mentioned, we're doing this as a non-profit initiative. We're being sponsored by our day job, really, to build this thing out. More companies are getting involved. Ericsson have contributed a bunch of technology to this. They've also released an open source home server written in Go. Other companies too, and other individuals are getting involved. But this is very ambitious. This is crazy. It's a moonshot. I was talking to some of my colleagues earlier, and they were saying, hey, people have tried to do this so many times, and the market just doesn't want interoperability. Businesses don't want federation. I don't believe that. for the reasons at the beginning, I still think that there is a utopia, a world where we as users can actually have communication that interoperates. And I don't think we should give up on it, but it requires a huge change to get to the point that Facebook or Google would say, hey, we should be interoperating with Matrix rather than creating this island, this silo. And it's basically a perception problem, it's a marketing problem. It's like going from the old commercial Unixes, Solaris and IRIX and AIX and all those things, through to Linux. It needs somebody to, well, it needs a bunch of people to be crazy enough to try to make it happen. And that's what I'm doing, standing here in Bogotá, trying to explain the mission that we're trying to do. And what we need is for people ready to run servers, help us debug them, join the Matrix Federation. We need people to write gateways to their existing services. So if you love Asterisk, you love Elastix, you love XMPP, you love OpenFire, then please run a gateway into Matrix, or help us write one, help us debug them. We need people to tell us whether it sucks. The APIs are obviously the key thing here, and there are some controversial things, and there are some bugs. Nothing is frozen yet, we are still in beta, we want to get it right. So if you think that everything should be WebSockets, or everything should be using EBIDIC rather than UTF-8, then please tell us. If you're writing a new app, then just try building it on Matrix. We have given you all the building blocks here to create pretty much anything. It's all beta, but some of us like working on emerging beta stuff. A really useful thing would just be to follow us on Twitter and tell everybody you know about these stupid European crazy types who have this dream, and it may work, it may not work, but just tell everybody about it, please, and have a play and see if it works. So thank you very much for listening to me. I'm sorry that it's not in Spanish, and I'm sorry that my accent is strange, even if you were intimately familiar with English. And I guess I've finished a few minutes early. So if anybody has any questions, complaints, please ask away. Yes. Yeah, they sure are. So the question there was, for the end-to-end encryption in a distributed environment, is somebody looking at the legal implications? And the reason nothing has happened on end-to-end encryption between July, if we look at our timeline, and where's our timeline gone? Yeah, so between July, when we shipped on, and today, nothing has happened on end-to-end encryption because the people funding us asked that very responsible question, and we've been working with a bunch of lawyers to go through the implications of what is going on there. And that has implications for data ownership. I'm sure folks are familiar that safe harbor between Europe and America was just cancelled basically 2 days ago. And there are all sorts of data protection issues as you import and export data from different countries, as well as the lawful intercept requirements that many governments have, quite rightly, to avoid people using a system like this for terrorism or being bad guys, etc. So yeah, we are very aware of the considerations there, and we have, I hope, the right balance of letting people who need to be, how can I put this? If you were a telco and you were launching a Matrix service and your license depends on being able to work with the authorities to go and use, to retain your license, then the encryption that you would put in your client would probably have to have some kind of backdoor to allow you to work with the government. And you ship your client, you do that, it's your problem. Matrix doesn't have any native support for that, but there is nothing stopping people writing a Matrix client that goes and does naughty things. If, on the other hand, you are enormously privacy concerned and you never want anybody to get at your private keys, don't speak to people using those clients. So it's a really difficult problem because obviously we don't want to be responsible for unleashing something that is going to make the world a worse place. But then again, the idea of just handing over private keys to anybody who asks can also be a problem. Sorry for the slightly hand-wavy question, but it's something we've thought about a lot. Any other questions?
Yes. So I got two small questions.
Sure.
So first, quick presentation, thanks.
Thanks.
So I have a question about identity. So I just downloaded the Matrix Android app to post those things in.
Yep.
And I got prompted for nickname or something.
Yep.
Then you use the Skype, so you use like validation of that, and you connect it to IRC where you have another name. Then somewhere else you have another name. So how do we know who are you?
Great question, and I kind of glossed over it earlier when I said it's a 3-hour seminar to answer properly. Probably the best answer I can give. Well, first of all, at the moment we have identity services which map from any identity, Skype, email, phone number, through to a Matrix ID, but they're centralized. This is a huge problem for Matrix because the whole point of Matrix is that there is no single organization managing that kind of database. So what we've done, what we're working on is decentralizing it, but it's really hard. It is the problem of fixing spam, as in, why should I believe your server to claim that you are who you say you are? But there was some really interesting research there with things like the Stellar Consensus Protocol and WebFist and WebFinger from Brad Fitzpatrick and a bunch of other people who have tried to solve this problem. I can show you a presentation on it afterwards that we gave at our RTC conference in Chicago on Monday, and it's, well, we need people to help on it. If you're interested in solving the identity problem, then let's go and talk about it afterwards. Thank you very much, everybody, for listening to me. Thank you for listening.